Okay, so this is just going to be a really basic getting started in Jupyter Notebook tutorial, as was requested from the fall 2018 semester of Math 1 LS3 students. So I'm going to try to do this from scratch. You can pause and work along with the video. You can watch it once and then try it on your own. Many of these things might seem obvious to you, but just based on the experiences of past students, I thought I would include them anyway, because if it helps one person, then it's worthwhile to include. So I do apologize if you have extensive computer programming knowledge and some of this seems basic, but I just learned this year and it wasn't basic to me. So these are all things that I've learned and I've had to, of course, remember in order to effectively use this system. So the first thing I'm going to do is I'm just going to access our fall 2018 webpage. Let's see. Okay, click. Now, I tried to wipe away all of my saved information, so it will look like it should look to you the first time you access it, but of course some things are automatically saved in my laptop. So I'm going to click on, let's start with Computer Labs. Right, read this first to access. Okay, well, let's not do that together. Okay. I'm going to be using the online version of Jupyter Notebook because it's the easiest to use. You can access it from anywhere, any computer, so it's very convenient. However, being that it's online, it's subject to problems, crashing. If you lose your connection and you didn't save your file, you might lose some of your code. So there's problems associated with it, but it's easy and it's a great choice for lazy people like myself. If you think you're going to be doing more computer programming or you want like a more resilient version, you can download it to your laptop completely free. And then of course it's more permanent and it's not going to have as many problems. But this works fine for me. I put up with the little glitches because again, I'm lazy and this works. Okay, so obviously I didn't have to put my login information. I guess it's just saved in here. Does it say my name anywhere? No, it doesn't. All right. So what are we going to do? This is a Jupyter Notebook. Now you'll be actually uploading ones from the webpage. First, you'll download them from the webpage and then upload them into this server here. So I'm going to just show you how to start a new one. So here you can actually write two languages supported by this. We've got, supports Python 3 and R. We're going to be using Python 3. So this is what I click on. Great. Here we go. Oh, awesome. There we go. Are we in? I think we're in. Looks good. Okay. If you want to, you can give your notebook a title. My first Jupyter Notebook. That looks nice. Is it saving? Yeah. Save. Yeah, okay. This is a cell. Okay, in the first cell, we can choose to type code or notes to ourselves. So I actually like to break up my code with tons and tons of notes to myself. It's just my style, I guess, my coding style that I'm developing for myself. So from this little menu, you can decide if you're going to do Markdown, which is just regular HTML, or if you're going to code something. So I'm just going to start with, I don't know, something. Now, I don't know all the codes to this offhand. I don't do anything fancy. So I do know a couple of things, like if we just want to do a header, I mean, you can change colors, you can change the font, you can do, of course, you can make a web page, but that's not the goal here. So my first attempt at coding. Maybe we should have capitalized. I don't know. That's fine, I think. Okay, no. End heading 1. Let's run it. So to run, you can use shortcuts. There's a whole list. I'm sure there's a little tutorial you can watch for that. Of course, you can just use the buttons here. Awesome. It's nice and big. And then underneath it, you can just type, anything. Like, and run it. You get something that looks, oh, let's run it again. All right, there you go. Now, the default state is that you're going to be typing code. So of course, if you try to type something random here, it will think it is code and something weird might happen. I don't know, actually. Yeah, there we go. Of course, because it's not code. So if you want, you can always go back and then just change it to Markdown. There you go. I don't like that, though. I want us to look kind of nice, so I'm going to cut that out. Okay, great. Let's type some code. Now, the first thing that we're going to do, and usually you just copy and paste this. I cheated. I have this little notes to myself off here that I was going to copy and paste. Can I remember it? Maybe. So the first thing that you do for the math coding is you want to import some special math packages, right? Jupyter Notebooks can do so many things, and if all the packages required to perform those functions were present, like were in the background, it would really slow it down. So we import the bare minimum that we need to do what we need to do. So you'll just be copying and pasting this in a cell. You don't have to remember this. I'm not even sure if I'll be able to remember it, but let's try. So first thing I'm going to do is going to define what the cell is going to do. If you put this hashtag in front of anything, basically the program ignores it. So you can also do notes to yourself by just putting a hashtag in front of them. So here I will import packages and assign shortcuts. Import packages to be used in Math 103 and assign shortcuts. Okay, so if I run this, it will do nothing because it's completely ignored it. This is called commenting out a line of code. Okay, so import matplotlib.py. This is a math plotting library. It will allow you to plot nice graphs, points, whatever. And we don't want to type that each time, so we assign it a shortcut. Import numpy. We'll run it. Okay, if you run it, so my suggestion is to just type a little bit of code rather than fill out the whole thing to run it only to see it won't work. Type one little thing, run it. If there's no problems, you're good to go, right? So it's better to do frequent checks by running it than to type hundreds of lines, run it, and of course you have bugs all over the place. Okay, what else do we want to do? Let's do matplotlib inline. That's what I'm not sure about. Yes, okay. So this right here, NumPy, this is actually, it's a math package which allows you to call functions, to refer to functions like cosine, arctangent, logarithms, right? You can just write like, for example, y equals, and I mean, this won't run because I haven't defined x yet, but mp.cos x. Actually, we could say x equals 1 from -1 to 1. Let's take 100 values, and then y would be cosine of those x values. Okay, what I just did here is I defined a linear space of x values, so going between -1 and 1, creating 100 equally spaced values between -1 and 1. And then y simply computes the y values for each of those x values. Did I do it right? I don't even know. Well, what you can do is you can run it and there was no errors, so that's done right. Now we're not doing that yet, so let me just comment it out. Great, okay. So I start all of my files like this, and I'll just open up an old one that I do and I copy, and then I just paste, bam, done. Run that, and I'm good to go with any math coding I want to do after. If you lose your connection, okay, so this is important because this is one of the issues we had a lot. If the connection, you lose it even for a second, you might not even notice, these packages are kicked out. So what will happen, let's just see. I don't know because I've already run it. I actually don't know if they're going to be still in the program. I'm not sure about this. Let's see. Okay. So let's say we tried this code here. Would this work? Yeah, I guess it still knows because I've already imported it. It's in the background. Okay, I just wasn't sure about that. Let's get rid of that. Okay. Oh no. Where's the undo? Oh my gosh. Actually, I don't know. Is there an undo? Maybe not. Oh, yes. Oh my gosh. Okay, sorry. Sorry. Okay, it's very professional. I don't even know if I'm able to edit this. Likely not. This is embarrassing. Okay, what should we do? Let's just move on, shall we? I'm just gonna run this again, because when in doubt, just rerun. Okay, let's do some plotting basics. So let's start by defining an array. This is an array. I'm going to create an array of x values. 1, 2, 3, 4. And I'm going to create an array of y values. I don't know. 3, 4, 18, minus 2. Okay. And I'd like the size of each to be the same. You can actually print that. You can print the length of x. That should say 4. Great, awesome, okay? Or the length of y is, yeah, shocker, 4 as well. Okay, let's get out of there. You don't need to do that. This print function is actually nice if you've created something, you've done something, and you're not really sure what's going on behind the scenes. You can print it and then just examine to make sure it's working all right. Okay. So let's plot these values, shall we? So for plotting options, I usually just use scatter plot or plot. So I'm going to plt, is that what it is? Yeah, plt dot scatter x and y. There you go. Okay. And I'm going to plt show, and I think that gets rid of that. Yes, it does. It gets rid of that weird header there. All right. This is really all you need. You can add fancy stuff now if you want. It's not even really fancy, but you can add a title. My first scatter plot. Lots of firsts here today. Nice. What? What's going on? Oh, right, because I did it after show. So it showed it first and then printed that. That's not good. There we go. Okay. This is why it's good to run after making some small modification. Dot x label x and then copy paste. Oh, it's looking good, right? You can do legends, you can change color, you can, I mean, this is fun, right? So I think up here you can do color, oh, right? Red? I'll do red. Yeah, sure, whatever. Okay. But again, I mean, if it's your first time doing it, you can layer on the complexities as you go. So this looks good. Pretty happy with this. And now anytime I want to plot something, I'm not going to type that again. I'm just going to copy and paste that and then edit the labels, right? Okay. So now let's define a function. Okay. Do I need something separate? Okay. X equals 1, 2. Oh, actually. Let's try this. Let's just create empty arrays. I mean, there's multiple ways to define a function. I'm just going to show you some options. It's not comprehensive, but it's a good place to get started. Okay, so I'm going to do a little loop. So let's title this my first loop. Okay. So for I in range, how many values do we want to do? So maybe go 1. Start at 1. If we want to do 10 values, you actually have to go to 11. That's just how this works. Now, it's about to do a loop, which means it will repeatedly do something. Starting so I is your index, and you're going to go start at the value 1, and then go 2, 3, 4. It will count up through to 10, and then come out of the loop. So for I in the range 1 to 11, your xi will equal I. Your yi will equal x, or let's see, xi, let's do squared, y equals x squared. For square, so x squared, it's my cat in the background. Yes, I'll get food later. Like this. Okay, so that would actually be x squared. If you wanted to do 2 times x, it's just a single star. So let's do x squared. And then let's do append, or let's see, x to my x array above, which is right here. I'm going to append xi. And we can do the same thing. To my y array, we're going to append this newly computed yi value. Did it work? Who knows? Let's print some stuff. Okay, so we don't want an indent. So notice your loop. For I in the range 1 to 11, or it's really going to go from values 1 to 10, this is what xi will be. This is what yi will be. So it will compute xi, compute yi, and then it will add that new value to the array and add the new y value to the array. So it will do this for 1. So we would expect to see the first value should be 1 and then 1 squared. And then those values are added in, and then you exit the loop and you come through again with the I value of 2. So then x2 should be, or xi should be 2, and then yi would be 2 squared, which is 4. So just to make sure this is working, sometimes I like to print, so out of the loop, let's print x and print y. So here's x, 1, 2, 3, up to 10, just like we thought, and then the square is great. Wonderful. Okay, and we can, of course, scatter those if we wanted to do a plot. Maybe we won't do the plot here. What if you didn't want to print all values? Okay, what if you just wanted to print the initial values? So inside the array, the very first values would be called x0 and y0. So you can actually specify that you just want to print x0, and you use square brackets to indicate the subscript or the index, right? y0, okay. Good, right? So you can print 0, you can print, I mean, if you wanted the third entry, okay, and so on. Actually, you know what would be helpful? If I just printed the full ones, this might illustrate this better. No extra spacing, bad, bad, bad. There we go. So if you want the initial ones, 1, 1, so that's 0, entry 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if you wanted the last ones, of course, you'd have to do 9. It's kind of strange to me anyway that these are labeled 0 and then that's 9 and then you're going from 1 to 10, right? But again, it's just a convention to get used to. Okay, wonderful. Are we happy with this? Okay. What if you wanted to print the ordered pairs? Like this usually isn't how we list, you know, here are the x values, here are the y values. What if, you know, wouldn't it be nice to have them side by side? So I think you can actually do that. What if we do, like put in, if you just want to print text, you have to put quotations around like everything. It's annoying, but again, once you type it out the first time, you never type it from scratch again. Comma, x value. I'm not even doing this again. That's how lazy I am. Let's change that. And then let's do another comma. I know I'm going to mess up the commas here, but that's fine. Oh, actually want commas and quotations. Comma after that. Is this necessary? Some of you might be shaking your head like, what is she doing? I don't know. Once it's worked, I'm not a computer scientist. I know what I need to know and kind of nothing more about programming. If this works, I'm going to be happy with it. Nothing I do is really going to, I mean, in this course is really going to slow this down. Oh, okay. Where did that come in? Yeah, what am I doing? Totally don't need that. I need this look long. Great, awesome, wonderful. What if you want all the ordered pairs printed like that? Sure, we can do that. Here's one way to do it. Print 0. Copy, paste, 1, 1, paste, 2, okay, and continue. And you're bored already, right? Well, if you're just going to change the index all the way up like this, then this would be a perfect opportunity to use a loop, right? For I in range 1 to 11, print xi, yi. But we want this to go 0, and this will actually, we want it to go up to the 9th entry, so we should make that number 10. Dun, dun, dun. Oh, it looks so good. And so these are useless to me, and I don't particularly want this anymore either. Very happy with this. Great. I don't like extra space, and so that, all right, I'm happy with this. Loops, there's 2 loops there, so okay. Wonderful. Okay. So I'm going to show you another option for actually generating values of a function that I prefer to use. So I like to use, I come up to this, I'm going to use this NumPy package, right? So x equals, you can actually, let me show you something. You can type the values right in, np dot, oh yeah, linear space, lin space. You can go like maybe from -10 to 10 and make 100 values in there. What actually I think looks kind of more sophisticated is to put your endpoints up here. And then if you want to change it up, right, so let's put it as A, B, put these parameters in like this. Then if you wanted to change it up, all you have to do is change the values at the beginning of your code. You don't have to go through different lines and walk in here and start changing A and B and potentially mess up a comma or something, right? I don't know. I think it looks, I mean, who am I to talk about sophisticated code? I really shouldn't, but I think this looks nice. I like doing all my edits at the beginning and minimal edits throughout the main body of the code, I guess. Okay, so this is actually going to define, if I make this small enough, I can show you what it will do. So let me just go, let's maybe just, I mean, I guess we can do 100, it doesn't really matter. Print x. So it goes between -10 and +10, and it will create an array of 20 equally spaced values between -10 and +10. Okay, so it's great. You don't have to type, did I type them out here? No, but you didn't have to use a loop for it. Okay. Now your y value will be x squared. And you can print y just to make sure your code's all working. Yes, that looks all good. And now let's plot. Instead of, we can do scatter plot, x, y. Oh, right, and then line. I don't like that, so plt show. Okay, and now here's another option. If you don't want the scatter plot, if you'd like to connect them, then just replace scatter with plot, right? Here, it's kind of choppy. How do we make it smoother? That's right. More points. And everything is an approximation, right? So you can just always improve on it by, changing conditions. All right, looks good. While we're here, let me just show you actually some of these other functions we can do. -10 to 10. Do you guys want to see? Let's do cosec. Nice, right? You can even put a grid if you like it. That's pretty. Yeah, good. Okay. You could do, what else? What do we like? exp. So that's actually e to the x. Looking good. Log. Oh, you are not happy because negative values should not be going in there. No problem. There. Right? See, this is, again, this is where I like to put my parameters at the beginning. Okay, that's good, right? Okay, what else did I want to show you? Oh, if you wanted multiple plots, I'm sorry, I was looking at my little list of things to talk about. If we wanted to plot 2 graphs, we could call this 1. Actually, let's go back to, no, we can put e to the x on here too, why not? Let's call this y1, so we're going to plot y1, make sure that still runs. Yes, we're happy with that. And then if I want to use my same set of x values, right? Let's do that. We can define y2 equals np cosine x. And then we're going to plot y2 as a function of x. Cool, right? Maybe you want a legend. But I don't know if I know how to do this. I think you put, so this is equals ln x equals cos x. Oops. I don't know. No, okay. Oh, I think you have to do title. Shoot. No, now I forget. I've done that somewhere else. Oh, that's, Okay, sorry, I was gonna add something to this. I'd have to look up some old code and I deleted it. Okay, yes, that's fine. It's because I can't figure it out right now. Really? I really thought it was after this. Oh, I think I know. Yes. Okay, great. Moving on. That might be it. Was there anything else? So that's how you could plot multiple graphs. Let me just check. Oh, yeah, I think just what I wanted to, the last thing I wanted to show you is what you're going to actually be doing. Okay, so I'm going to start a new one, or we'll go back to our file. Can we get back there? Just save first and go back. There we go. So what we'd like to do is download. So where's my computer lab? Work on introductory lab. Okay. And device, save it. If you download this multiple times, let me see. Let's go. Let's see. Where did this come from? Oh, it's automatically pulling it. Sorry. You might have to unzip it. So this, again, this is the problem. I downloaded this back in September, but here it is. So you would select it now. Here's some issues that I'll just quickly mention. If you've downloaded this or unzipped it multiple times, sometimes your computer will add something to the file extension. This will create something that looks very, very bad. See? Okay. And this was a lot. I mean, a lot of students came during office hours with something that looked like this, like, what's going on? Well, Jupyter Notebook is just interpreting this as a text file, plain text. So not good. You cannot have anything. Oops, sorry, I've done it again. Anything after your extension, or it will not interpret it as a Python notebook. So let's try it again. So it's got to be clean. It's nice and unzipped. So you'll download it as a zip file, you unzip it, and then you upload this file with no modifications to the extension. Okay, now you can see it's a notebook. It has a little notebook picture, so we're happy with that. So this is what you're going to be working with. Wow, there's a lot of comments. Lots and lots of comments. This is the only code. See, we start by importing the packages, and we always run this cell first. Here we go. To start, run this cell. So it's going to print a space, print you're ready to go, and then print another space. So we run it. There you go. So now it kind of goes into more detail, more formal definitions, I'm sure, than what I kind of outlined for you, but you can work through this initial lab yourself. Remember to save frequently, right? And again, if for some reason, if it says, I wanted to show you, I should have showed you an error before let's try that. One more thing, just a common error that I saw. So let's get rid of these. Okay, and let's upload. Okay, so go into here. If you forget to run this first cell and you don't have these packages, right? Or if you lose a connection for a tiny amount of time, right, then these packages are kicked out. So it could be that down here, you're trying to do something like x equals np linspace, just like we did before, to 10. That won't work for different reasons. Y equals x squared. And then maybe you want to print x and then print y after it. Okay. What's going on? Name error. This NP is not defined. This is a really common error, which and what this means is it has no idea what you're referring to, right? You're trying to call this package and it's not there. So to fix this, and then again, sometimes this might not even work, but usually you would just run your first cell. So you've imported the packages and then try this again. There we go. Okay. I have had a problem when using the online version where even when I do that, it still won't. I mean, sometimes I just have to close the entire program, restart it, and upload a fresh lab. That has always worked for me. And I'm not quite sure why, even when I go back and run a cell, sometimes it doesn't seem to function the way that it did when I first uploaded it. Maybe I corrupted it somehow. When you start going through messing and editing, it's hard, maybe you threw a comma in somewhere or a space that's messing with it. And it is hard to go through line by line. And that's why I sometimes just give up, close it all out, and upload a fresh one, okay? I also try not to mess with the cells that are already there, right? If I wanted to mess around a lot, if I'm doing a small modification, like just changing a number, sure, that's okay, right? But if I'm going to be doing like some major coding, I would actually take my code that I know that works, and I'm not going to mess with it. I copy it, paste it in a new cell. Did I totally mess that up? Yeah, I did. Sorry. Take my code, copy it, paste it in a new cell, and then mess around with that cell. Right? So that if there's some crazy mistake, that's not a problem. I'll just get rid of that cell, and then I'll go back and work from the one that I know is already working. Okay, so my computer's about to die, and I think I've probably covered what I intended to cover. So I hope that you find this helpful and not too long-winded. And I look forward to seeing you in class. Thanks.